interference ministry questions. Question number 1, which of the following must be true for two waves with identical amplitude and wavelengths to undergo complete destructive interference? In destructive interference, one crest and one trough must meet, so they must be out of phase by 180 degrees. In this case, they are going to cancel each other if they have equal amplitudes. So the waves must be 180 degree out of phase at all times. C is the correct answer. Question number 2, coherence is the correlation between the waves of two or more between the phases of two or more waves when the waves have the same wavelength and preserve constant phase difference. And phase angle difference between the waves must be unchanged, which means they have this constant phase difference. If they are in phase, always in phase, all the time in phase. In phase, we did say that out of phase, that always out of phase. So which is called coherence. Question number 3, the correlation between the phase of two or more waves. So it is the definition of coherence again. Question number 4, what is the necessary condition for a path length difference between two waves that interfere constructively? So constructive interference happens if the path length difference is 0, lambda, 2 lambda, 3 lambda, and so on. So odd integral number of the half wavelength, odd, 3, 1, 5. So half wavelength, which if you say like this, it's going to be 1.5. It's not, as you say. This is destructive interference, condition for destructive interference. Integral number of wavelength, yes, integral means 1, 2, 3, 4, 5, and so on. Odd number of the wavelength, yes, odd is correct, but not complete. 1, 3, 5, lambda. So correct, but not all of them. Is this also even could be? Even integral numbers is yes. The C and D are one part of the answer, but not complete answer. Complete answer is B. What is the necessary condition for path length difference between two waves of that interfere destructively? So for destructive interference, path length difference must be lambda over 2, 3 lambda over 2, 5 lambda over 2, yani. So odd integral 1, 3, 5, 7. So odd integral number of half wavelength. So we multiply these odd numbers by lambda over 2. Lambda over 2 is half wavelength. So odd integral number of half wavelength is the answer. Question number 6, in the interference pattern, if the path difference between two waves is 3 lambda over 2, 3 lambda over 2, the blah blah fringe appears on the Vivan screen. For dark fringe, it will start like 0.5 lambda for the first dark, 1.5 lambda for the second dark, 2.5 lambda for the third dark. It goes on like this. So this is first dark. This is second dark. This is third dark. So 3 lambda over 2 is 1.5 lambda. So it is going to be second order dark fringe. Question number 7, in an interference pattern, if the path difference in angle between two waves is 3 pi radian, the fringe appears on a wave stream like what? Remember, for bright fringes, it was 0, lambda, 2 lambda, 3 lambda, and so on. And each wavelength corresponds to a phase angle difference of 2 pi. So lambda is 2 pi. 2 lambda is 4 pi, 3 lambda is 6 pi. So as you see, 3 pi is not between them. So 3 pi is not them, so it's between them. Between them means it's going to be dark. Which dark? So remember, first for dark fringe, it starts by lambda over 2, 0.5 lambda, 1.5 lambda, 3 lambda over 2, 5 lambda over 2. It goes on like this, and lambda over 2 is pi. So 3 lambda over 2, 3 pi. 5 lambda over 2, 5 pi. So as you see, for dark fringes, phase angle difference is 3 pi. It is even the second dark. This is the first dark. This is second dark. This is third dark. It goes on like this. So it's going to be second order dark fringe, and C is the answer. The difference in distance traveled by two beams when they're scattered in different direction, in the same direction from the different points, This is the definition of the path difference or path length difference. Because of the great distance from us, stars are essentially point sources of light. If two stars were near to each other in the sky, the light from them would not produce an interference pattern because the light of the two stars are not coherent. So they're independent light sources. Independent light sources cannot produce a interference pattern. We cannot see it. We cannot observe interference pattern if they are independent light sources. These two light sources, stars are independent light sources, so that's why they are not coherent. They cannot produce an observable interference pattern. I think this is all about the first part of the interference. Now we will continue the second part of the interference. Question number 1. In the equation for interference, what does the term D represent? Remember, D sine theta is equal to m times lambda, or m plus 1 over 2 lambda for dark. So this D is the slit spacing or separation between the slits. So the distance between two bright, distance from midpoint to the two slits. No, it's not that. Distance between two slits through which the light passes. So this is the correct answer. Question number 2. Which of the following expression correctly describes the condition for observing the central bright fringe in interference pattern? Central bright fringe path length difference must be 0. Yani path length difference is d sine theta must be equal to 0. So A is the correct answer. And question number 3. Which of the following expression correctly describes the condition for observing the first dark fringe in the interference pattern? Remember, for first dark fringe, path length difference was lambda over 2, so d sine theta is the path length difference. It must be equal to lambda over 2, so this is D. Which of the following expression correctly describes the condition for observing the fourth dark fringe? So let's start like this. First dark fringe, lambda over 2. Second one is 3 lambda over 2 and 1.5 lambda. Third one is 5 lambda over 2. It goes on this way. Fourth one is 7 lambda over 2. It goes on like this. So fourth dark fringe, this is first dark, second dark, third dark, fourth dark. So it is going to be fourth dark and 7 lambda over 2. Of course, you can also use the equation for dark fringes. It was d sine theta m plus 1 over 2 lambda. But m will start with the, if it is the fourth dark fringe, you are going to write for m3. So the sine theta is going to be, remember, m is always 1 less than the given order of the dark, 3 plus 1 over 2 lambda. So 3 plus 1 over 2 becomes 7 over 2 lambda. So again, same answer. Question number 5. Monochromatic infrared waves with the wavelength of 750 nanometer pass through two narrow slits. If the slits are 25 millimeter apart, at what angle approximately will the fourth order bright fringe appear on the viewing screen? So lambda is given to us, separation between the slits given, and the fourth order bright fringe m is equal to 4 is given. So we are going to use d sine theta is equal to m times lambda, because angle is the question. Sine theta is equal to m lambda over d. M is 4, lambda is 750 nanometer, converted to meter 10 to the power of negative 9. So use, okay, divided by the distance is equal to 25 micrometer. Micrometer is 10 to the power of negative 6 meters. So we are going to use the calculator now. So it's 4 times 750 times 10 to the power of negative 9 divided by 25 times 10 to the power of negative 6. Close the bracket. Answer is 0.12. 0.12 is the sine theta. We are looking for theta. So shift, you should press shift inverse, which is the sine inverse. Answer. So it's going to be 2.1. It is 2.1. I'm going to do it again. I think it's not 2.1. Once again. shift sine 0.12. But it's not 2.1, it is 6.9 degrees. So it's the correct answer. And question number 6, light falls on a double slit with the slit separation of 2.02 times 10 to the power of 6 meter, which is D, and first bright fringe, which is M, is equal to 1, seen at an angle of theta. So relative to the central maximum, find a wavelength. Lambda is the question this time. Again, I'm going to use D sine theta is equal to M lambda equation, but this time I will find lambda, which is equal to D sine theta over M. D is 2.02 times 10 to the power of negative 6. Sine theta sine of 16.5 degrees divided by M is first right fringe. So then we are going to use the calculator. So 2.02 times 10 to the power of negative 6 times sine of 16.5. Answer is, so it's going to be lambda is equal to 5.74 times 10 to the power of negative 7 meter. To convert it to nanometer, because choices are given nanometer, we should multiply this by 10 to the power of positive 9. So multiply by 10 to the power of positive 9. So you will convert it to nanometer. It's going to be 574 nanometer. So A is the correct answer. Distance between two slits is 30 micrometer, which is D. The second order bright fringe, which is M, is equal to 2. Measured on a wave string of theta. Sine theta is given this time. Calculate the wavelength lambda. That is much easier than previous one. Again, I'm going to use lambda is equal to D sine theta divided by M. D is 30 micrometer to meter 10 to the power of negative 6. Sine theta itself is given 0.037 divided by, it is the second order divided by 2. I'm going to use the calculator. 30 times 10 to the power of negative 6 times 0.037 divided by 2 is the answer. 555. Yeah, 5.55 times 10 to the power negative 7 in meter. So, but answer again given in nanometers, so it's going to be multiplied by 10 to the power of 9. So you are going to get the answer 555 nanometers. So B is the correct answer. Question number 8. The distance between two slits is 0.03 meter, which is D. The second order bright fringe, again, M is equal to 2. Measured angle is again given. I think, is it the same question? Distance between the two slits. Yes, it's the same question. Only difference, millimeter is given this time, not micrometer. Everything is the same. Most probably answer is the same again. So check 7B, yes. 8 is D, most probably. Yes, that's almost the same. Question number 9. If the double slit interference experiment were performed for the light rays with different colors, blue, red, yellow, and orange and yellow, angular displacement for which is larger? Angular displacement is theta. You are going to look for sine theta. So sine theta is equal to m lambda divided by d. So if we want a larger theta, so wavelength must be longer wavelength. Longer wavelength, of course, for blue, red, orange, or yellow. Which one is longer wavelength? Of course, red is the longest wavelength. So that's why red will have the largest angular displacement. Then question number 10. An interference pattern is formed by using green light. If two slits are moved further apart, what happens to the distance between the bright fringes? Again, distance between the bright fringes are related to angle theta. So you can use the equation which calculates theta, m lambda over d. This time, these slits moved further means d, we increase d. Increasing d causes sine theta to decrease. If sine theta decreases, of course, the fringe on the screen will get closer. Yeah, and separation Distance between two bright fringe decreases, and B is going to be answer. And question number 11, the figure shows the pattern of double slit interference experiment. The center maximum located E, this is central maximum, and M is equal to 0. Each point represents second order minimum, So this is first bright, this is second bright, this is like bright B, second bright, central bright. This is first dark. So this is second dark. So on the right edge, but on the left also we have it. So this is first dark, this is first bright, second dark, and second bright. So second dark, the question, minimum is dark. So B is also correct. And B and H, B and H, H and B, D is the correct answer. And question number 12, if a double slit experiment were performed underwater, so how would the observed interference pattern be affected and why? So if the question is about interference pattern, how pattern changes, theta must be checked in the equation. Sine theta is equal to m lambda divided by d. So if light moves from air to water, its speed decreases. You studied this in the 10th grade. Speed is of the light in the water is smaller. Speed and wavelength are directly proportional. If speed gets shorter, smaller, and the wavelength gets shorter. Shorter wavelength means separation between the fringes decreases. Yani interference pattern decreases because lambda gets shorter. In water, it would decrease because lambda gets shorter in water. So is the correct answer. And question number 13, a beam containing light of wavelength lambda 1 and lambda 2 passes through a set of parallel slits. The interference pattern of the fourth bright line of lambda 1. So M1 is equal to 4 occurs at the same position, and they have the same theta. Thetas are same position means they have the same theta. Fifth bright line of the another one. So for second one, it is 5, and again bright. Lambda 1 is this, lambda 2 is that. They have the same position. So d sine theta is equal to m times lambda is the equation. Because they have the same position, and because they have passing through the same parallel, so this side is same for both fringes. Yani fourth bright line of lambda 1 and fifth bright line of lambda 2 on the left side of the equations are the same. The right side also must be the same. Yani m1 times lambda 1 for the first light, m2 times lambda 2 for the second line must be equal. They both are equal to d sine theta, which is the same. M1 is fourth bright line, lambda 1 is given 540, M2 is fifth bright line, lambda 2 is the question. Simplify it, divide them by 5. So you will get the answer, most probably is the correct answer. Let's check it again by calculator. So 4 times 540 divided by 5, answer is 432 nanometer is the answer. So this is all about interference and section 1.